Hello, mathematicians. Today we're going to be learning about the coordinate plane, more specifically how to identify the axis of reflection. To get us started, here we have a coordinate plane. And on our coordinate plane, we have our x-axis, which is the horizontal line on the graph, meaning it goes side to side. And we have our y-axis, which is the vertical line on our graph, which goes up and down. In the middle, we have our origin. The origin is where both the x-axis and y-axis meet, and it's represented by the coordinate 0, 0. The origin is where we start to plot any coordinate. So again, we have our x-axis and our y-axis. Whenever we're given a coordinate such as 3, 4, the first value is our x-coordinate. And we can locate this value on the x-axis. So if we have a positive x-coordinate, we're going to go to the right. And if we have a negative one, we're going to go to the left. Our second value here is our y-coordinate. And we can locate this value on the y-axis. A positive y-coordinate goes up and a negative one goes down. On a coordinate plane, a reflection happens when a point or shape flips over a line, like looking at a mirror image. The new reflected point is named using a prime symbol, and we'll go over that a little bit more. A reflection over the x-axis keeps the x-coordinate the same, while the y-coordinate changes sign. So the y-coordinate, if it's positive, it becomes negative, and if it's negative, it becomes positive. So for example, here we have point A, which is 2, 4. After reflecting over the x-axis, the new point is A prime, which is 2, negative 4. And in this case, because it reflected over the x-axis, the x-coordinate stayed the same, but the y-coordinate was 4, and now we have negative 4 for our reflection. So again, if we're reflecting over the x-axis, the x-coordinate stays the same, but the y-coordinate changes sign. So it becomes the opposite of what it was. If we had a reflection over the y-axis, then the y-coordinate stays the same while the x-coordinate changes sign. So a positive would become negative or a negative would become positive. So for example, here we have point B, which is at negative 3, 1. After reflecting over the y-axis, the new point would be B prime, which is 3, 1. So again, remember that our reflections do get that prime symbol. And in this case, if we look at point B and B prime, the x-coordinate changes sign. It was negative, and after reflecting it, it becomes positive. But the y-coordinate stays the same. So this is how we know we're reflecting over the y-axis. So let's go over an example. Here we have an example that says the point A prime, which is at negative 3, 4, is the result of reflecting A, which is 3, 4, on the coordinate plane. Identify the axis the point was reflected over. So we want to figure out if this point was reflected over the x-axis or the y-axis. So let's go ahead and write down the information we know. We know that the original coordinate was at 3, 4. So the x-coordinate was 3 and the y-coordinate was 4. We also know that after we reflected this point, our new coordinate, which is A prime, is now negative 3, and our y-coordinate is 4. In this case, the x-coordinates are opposites, and the y-coordinates are the same, meaning that point A was reflected across the y-axis. Let's go ahead and model this so we could visually see it. Again, here we have our x-axis and our y-axis. And here we have A and A prime. Notice that A is 3 units to the right of the y-axis, and A prime is 3 units to the left of the y-axis, meaning that it was reflected over the y-axis. If we look at these 2 points, they look like mirror images of each other through the y-axis. It's like someone standing in front of a mirror sees themselves equally as far from the mirror on the other side. So, A is reflected over the y-axis to then get A prime. Our next example says the point B prime, which is at 2, -1, is the result of reflecting B, which is at 2, 1, on the coordinate plane. Identify the axis the point was reflected over. So let's write down the information we know. So we know that B is the original coordinate, and the x-coordinate is 2, and the y-coordinate is 1. We know that B prime is the reflection, and the x-coordinate for B prime is 2, and the y-coordinate is -1. The y-coordinates in this case are opposites, and the x-coordinates are the same. This means point B was reflected across the x-axis. So let's have a visual so that we could see that. So again, here we have our x-axis and our y-axis. Here we have B and B prime. And if we take a look at B, we could see that this is 1 unit above the x-axis, and B prime is 1 unit below the x-axis. And we could see that they are mirror images of each other over the x-axis. So, point B was reflected over the x-axis to get B prime.